better now or not? It is connected. Microphone. Now you must be able to hear me well. Yeah, I disconnected the microphone. Okay, so how's it going, guys? Were you able to watch the first episode of DP series? Are everybody good? Are you all ready for the second session on it? Awesome. So today, as mentioned before, we're gonna solve 5 problems, one with difficulty 1600, one with difficulty 1800, 1900, 2000, and 2300. So I think without any further ado, we must start discussing the problems, and let's see how today will end up. Okay, so I'll move on to my screen to start talking about the first problem. Let me see if you can watch it well. Yeah, you are able to watch it. So, the first problem is this. You have a sequence. The sequence A is sent over the network as follows. This is the link of it. Let me send the link in the chats as well. So the problem A, the first problem states that you have a sequence A is sent over the network, and its sequence A is split into segments. Each element of the sequence belongs to exactly one segment, and each segment is a group of consecutive elements of sequence. So we have several segments, and we know that for each segment its length is written next to it, either to the left or to the right of it, and the resulting sequence B is sent over the network. So for example, in here you have 3 segments. One is only 1, one is 2 3 1, one is 2 3. So you have 3 segments. For each one of them you write their size either to the left of them or to the right of them. For example, for the first one, its size is 1, so you write 1 to the left of it. For the second one, its size is 3, so you write 3, for example, to the left of it. For the third one, its size is 2, so you write 2, for example, to the right of it. But you can also write on the other side of them. So you will write the size of each segment either to the left of it or to the right of it, and you are given this sequence B. And you need to say that, is it valid or not? Is it a way to interpret it as some segments such that their sizes is written either to the left of them or to the right of them, like any of these cases, or not? For example, again, in this example 1, its size is written to the right of it, this block, its size is written to the left of it, and this one is to the left of it. So you are given an array B, you need to say if it is valid or not. For example, the first one is valid because it's exactly like the example that we saw before. This is the first segment, its size is written here. This is the second one, its size is written here. And for example, this is the third one, and its size is written here. Is the statement clear? Okay, awesome. So let's now discuss about the solution of it. Well, when we have such a problem, how can we approach such a problem? Well, when we have such a problem, one way, if we want to use DP to solve such a problem, what do you think the definition of our DP can be? What do you think can be the definition of our DP? for example. So we have a sequence, we want to see if we can split it into segments or not. What do you think can be the definition of our DP here? So we know that from the previous session, we know that DP is about defining several subproblems DP is defining several subproblems that helps us to solve the main problem. The main problem is also one of those subproblems, and the point is that we define several subproblems because by doing that we know that these subproblems are going to help each other to be solved. So in here, what can we define our subproblems? So let's see. DP of I could represent whether that element is a part of a segment of, or if it represents a length. DP of I is valid. Yeah, these are great ideas. Yes, DP of I, this is a very good idea. DP of I can be if it is valid till index I. So I can define DP of I. So we want to see that how we can apply the ideas of DP in a problem like this. We want to see that how these different ideas of DP can be applied in these problems. For example, in here, one of the great ideas, this is for beginners. I mean, just focus on it. Everything that I'm discussing right now is for beginners. And it's something that everyone can understand. So please focus on it. I assume that you know nothing about DP, and we are practicing DP on several problems to see how it can be solved. So everything that I'm saying is without any need for any prior knowledge. Okay. So DP of I states that if the sequence from the beginning to the element number I is valid. So it is a Boolean array. It is Boolean. And it says that if it is valid till index I or it is not valid. So the point in here is that when we want to find out if DP of I is valid, there are two possibilities. I mean, we have some segments in here. We want to consider the last segment. If everything from the first index to index number I is valid, we want to consider the last segments that we have in the first I elements. There are two possibilities. Either in this last segment, its size is written to the right of it, or its size is written to the left of it. So these are these two conditions. First, let's consider the case that the size is written to the right of it, to the right of this last segments. Then how can I update DP of I? So let's do a recap. I want to see how dynamic programming can help me to solve a problem like this. I know that I have an array, I have a sequence. I want to see if I can split it into several segments. And I know that each segment, its size must be written either to the right of it or to the left of it. So this is my question. I want to apply DP on this problem, so I need to define several subproblems in order to solve this problem. Maybe I can define several subproblems such that these subproblems makes my work easier to solve the whole problem. So what can that be? That can be, for example, DP of I can try to understand, instead of finding if I can split the whole array into several segments, what I can do is to find out for every prefix of the array if it is valid, if I can split it into several subsequences or several subsegments or not. So dp of I can mean that if I only consider elements from 0 to I minus 1, for example, the first I elements, if it is possible to split these into some segments with their sizes. So there are two possibilities when I consider the first I elements. Okay, when I consider the first I elements, there are two possibilities. Either the size of the last segment is written to the right of it. Okay, and let's, for simplicity, let's assume that I use 1 base indexing. Let's use 1 base indexing in the explanation. So this is index 1, this is index 2, and this is index I. So assume that the size is to the right of the last segments. Then how can I find dp of I? How dp of I can be updated? Do you have any idea? dp of I is equal to, first, let's forget about the second possibility. Let's first consider if it is to the right of it. Exactly. This is exactly correct. Awesome. This is also correct. Awesome. So yes, exactly. The point is, if the size of the last segment is written to the right of it, we can say that dp of I can be updated as, from dp of I minus a sub I minus 1. Why? Because we have, we know that this index is a sub I. So what we can say is that if this is the size of the last segment, the segment must be in here and its size is ai. So the rest of the array, so I know that this way my last segment is this, and the rest of the array needs to be solved here. So I know that after this yellow parts, I know I have exactly one segment. And now recursively this part must be solved. So dp of I can be updated from dp of I minus ai minus 1. So if this is true, then this one becomes true. So this is the first case. The point is, if I consider the first I elements, if the last index is the size of the last segment, then I need to update my dp from dp of I minus a sub I minus 1. Right? Awesome. So this is the first case. So the first thing that I say when I calculate dp of I, this is how these sub-problems can help each other to be solved. I'm saying that if dp of I minus a sub I minus 1 was true, then dp of I is true. Or I can, in an easier way, say that dp of I or equal to dp of I minus a sub I minus 1. Okay, what about the other case? The case where the size of the last segment is to the left of it. This is the size. What can we do then? We can update dp of I plus a sub I plus 1 if... Exactly, yes. Well guys, in here we see something beautiful. In dp there are two cases. In dpi there are two ways. When we use dp, there are two ways to update the values of dp's. Either when I'm at point I will update dp of I will find dp of I using the previous dp's, or I do the other way. I do my updates like this. When I get to I, I presume that I already know dp of I, and I will use dp of I to update the next dp's. These are two different ways to calculate dp's. Either when I get to some index, I update it using the previous indices, or when I get to some index, I presume that I know this one, and I try to update the next ones using it. I can sometimes use both of the approaches at the same time. For example, in this problem, I can do the next thing this way. After this, I can consider that I will update the next dp's. I mean, when the size is to the left of somewhere, I do not update dp of I here. In this situation, this dp will update this one. So when I'm at j, I will update I automatically. So whenever I'm at any dp, like dpj, and dp of j is true, for example, j is here, and then I see that the next element is, for example, a of j plus 1, a sub j plus 1. Then I say that if dp of j was true, I will set dp of j plus a sub j plus 1 equal to true, because we can have the next segment like this. This can be the size, and then there can be a sub j plus 1 elements in here. So this dp will be true as well. So I will update this case will be updated in the other way. I will update it forwardly. I mean, when I'm at some points that I know its answer, it is true, I know that it is true, I will update the next indices. So for the first case, where the size is to the right of it, when I'm at I will use the size of ai to update dp of I using the previous dp's. But when I consider the case where the size is to the left of this new segment, I say that from the smallest value, when I had its dp, I will update the greatest values of dp's, and this way I can find out all the dp's. About your question, that's what bottom up means, bottom to top means. It is not bottom to top. There are two words, top down. There are two ways to calculate dp, top down or bottom up. Top down is the recursive way. When we have a big dp and we split it into smaller ones and then recursively call them, and they will be calculated, and then call them and they will be calculated. So top down means that I start. For example, when I want to calculate Fibonacci, first I will call f of n, and f of n itself calls f of n minus 1 and f of n minus 2 and so on, and I use memoization to make sure that my time complexity will not be exponential. This is gonna be top down approach. Bottom up approach means that I will start from the smallest one, like I have for I from 0 to n, for example, and then I calculate all the values from bottom and I go up. This is bottom up approach. So about your question, top down approach and bottom up approaches are like this. So this is something different. But in here, what I'm doing bottom up approach. But the point is about the way that I'm updating the values. The point is about the way that I'm updating the values. So I'm doing bottom up approach, but the point is that you have two ways to update when you do bottom up. Either when you get I, you will update everything that can be updated from I, or when you get I, you will calculate I using the values that can update I. So I'll do both. When I get to I, first I say that dp of I or equal to dp of I minus a sub I minus 1. And then I say that if dp of I was true, dp of I can be true in here, or it can become true by the previous j's the previous case might made dp of I equal to true. So I say that if dp of I was true, then I said dp of I plus a sub I plus 1 is equal to true. Or in other words, dp of I plus a sub I plus 1 or equal to dp of I. Is it completely clear? Is everything clear on this problem now? In the explanation about your question, in the explanation I used one-based indexing and inclusive indexes. So in my explanation, dp of I means if all the indexes from 1 to I are okay. I mean, this is valid. But in your code, it's better to use zero-based indexing and inclusive exclusive intervals. So instead of 1 to I, consider 0 to I minus 1 in your code. But in the explanation, for simplicity, I used one-based indexing, and dp of I means all the elements from 1 to I. Okay, if you are okay with that, please use this emoji or put a plus so that we can move on to the next problem. Second recursion, be if dp of I minus 1. In the second case, I'm just considering that if dp of I is true, I'm considering the case that another sequence will be started right after index I. So I'm just assuming that dp of I is true, and I'm considering that I start the next sequence from I plus 1. So a sub I plus 1 is the size of the next sequence, and then I have a sub I plus 1 elements. Okay, awesome. So let's move on to the next problem. The second problem that we want to discuss is this one, easy problem. Let me share the link with you. Easy problem is the name of the problem. It says that we have a contest, and each problem has a statement, and a statement is considered hard if and only if it has the word hard as a subsequence. So a statement is considered hard if it has the word hard as a subsequence. So, for example, these are hard, these statements are hard, for example, because this one has this H, this A, this R, this T, so it's hard. But these ones are not hard because they don't have hard as a subsequence. So now you are given a statement and you want to make it easy. You want to make sure that it doesn't have the word hard as a subsequence. And what you can do is to remove some of the characters. And you know that each character has some cost. For each of the characters, if you remove it, it has some cost for you. For example, it will increase the ambiguity by some value. So it has some cost. For example, removing this H has 3 costs. This H is 2 costs, and so on. You need to say that what is the minimum total cost that you can pay in order to make the statement easy. What is the, if you remove several characters, the cost of that is the sum of the cost of removing each element. You need to minimize the cost in order to make the statement easy. You have to say that what is that minimum value. Is the statement clear? Yes. We want to minimize over if we remove all the possible subsets. You want to consider a subset that can be removed to make the statement easy, and also it has minimum cost. Okay, so now again we have a string and we want to remove several characters from it in order to make sure that HARD will not appear as a subsequence. And we know that our string consists of lowercase English letters, and n, the length of it is up to 2 times 10 to the 5th. And the costs are up to 10 to the 9th. So the costs are up to 10 to the 9th. AIs. Around 10 to the 9th. So what can we do on this problem? What do you think our DP states can be? Again, maybe we can define several subproblems. Such that these subproblems can be easily calculated using each other. What do you think our subproblems can be? DP of I could be the minimum cost up it takes to make it easy. Yeah, that's the good starting point for idea. DP of I can be the prefix of length I. What is the cost of the prefix of length I? Yes. Why can't we do it without DP? I'm not saying that we can or we can't do it without DP. We're just trying to use DP to solve this problem. You can try to also solve it without using DP. That's completely okay. But we are just seeing this problem, and we want to see that if we want to define some subproblems, how would that be? Yeah, these are very good things, but there's also another thing that can be considered. Well, we want to get rid of hard. Okay, get rid of hard as a subsequence. So we need to know that in some scenarios, if you consider the first I elements, you say that DP of I can mean that what is the cost to make it easy. But making it easy, maybe we have a way to make it easy such that this part doesn't even have any H. So it doesn't even have any H or any A or any R or any D. It doesn't have any of these characters. This is one way, but another way of making it easy might be like this. Like H, there is an H here, there is an A here, and there is an R here. So it already has 3 characters. So the rest of if we're gonna add more characters later on to these states, these ones must not even have any D. So the point is making it easy, only making it easy is not the only information we need. We just need to know that, if we want to stop hard to be constructed, we just need to know that how much of it is made so far. So it's important that in this interval, the only question is not if hard is made or not. Even if some HA is formed, or H is formed, or HAR is formed, or nothing is formed, they are all different, and maybe you need to consider them all. You know what I'm talking about? Because if you only consider DP of I as to make the first I chars easy, this is not enough. We need to have more information about the first I characters. It's important that hard is made or not, but if it is not made, HAR, HA, or H, or nothing, it's important that which of these cases has happened. So yes, this is a very nice idea. We can have DP of I and J as the minimum cost to keep the first J letters within the prefix. Or let me see, DP of I and J is the minimum on the prefix of length I. Yes. So we don't exactly need mask, but but we can instead, we can have it like this. As you said, we can have like 4 states, dp of I and 4. What does dp of I and 0 mean? dp of I and 0 means that what is the minimum cost to make our first I characters in a way that it doesn't even have h. Because if you consider, if when we go from the beginning, we go forward and we have this H, I, R, D, these letters must be matched from the beginning. So first you need to match H with some character in here, then you need to match A with some character in here, then R with some character in here, and then D with some character in here. So nothing can be matched while H is not matched yet. Nothing can be matched if H itself is not matched yet. So if H is not matched, nothing is matched so far. dp of I and 0 can mean that what is the minimum cost such that we do not even have any H. So in other words, what is the minimum cost that nothing from H is matched so far? Okay, so it means that we want to make the first I characters in a way that nothing from hard is matched with any of the characters. It means that even the first character, H, could not be matched with anything. dp of I and 1 means that what is the minimum cost that we can have so that only H can be matched, but A cannot be matched. So it means that only H is, H has permission to be matched, but nothing more than that. So H can be matched, but A cannot be matched afterwards. dp of I and 1, dp of I and 2 means that what is the minimum cost that we can pay so that only H and A can be matched. So H and A have the permission to be matched, but the next character, R, cannot be matched. So this way we are considering all the cases. We are considering all the cases that how many first characters of hard are being matched with our string. And dp of I and 3 means that what is the minimum cost to remove some elements such that only H, A, and R have permission to be matched. And these are all our DPs. DP of I and 4 is not valid anymore because then all the characters are matched and we don't want that to happen. So the point is that what is gonna be our thresholds? How much do we accept to be matched? Maybe we don't want anything to be matched in this substring. In this prefix, maybe we don't want anything to be matched. Maybe we let only H to be matched, but we do not let A to be matched anymore. Maybe we let H and A to be matched, but we don't let R to be matched. Or maybe we'll let the first 3 characters, H, A, R, to be matched, but we do not let D to be matched. So we have 4 cases. And the point is that when we go forward on a string S, based on the characters that we encounter, we can update these DPs. Assume that you have DP of I minus 1 and everything. Now you want to find DP of I. There are several cases for I. For example, first assume that I is a character that is not in heart. I is a character that has no relationship with heart. For example, this S of I is X. This is an example. What do you do if S of I is X? How DPs will be calculated if S of I is X? How can we calculate our DPs if S of I is X? Exactly. If S of I is X, DP of I will be exactly equal to DP of I and J for any J is equal to DP of I minus 1 and J. So the point is that if S of I is something that is not related to heart at all. Then dp of I will be equal to dp of I and j will be equal to dp of I minus 1 and j. Because whatever we had before, we had the same thing. We still have the same thing. Nothing has changed. This x has no effect on anything. So nothing has changed. So in this case, and we do not even need to remove this character. We don't need to even consider removing this character. This character has no relationship with any of them. So in other words, if S of I is anything other than H or A or R or D, anything other than this, dp of I and j will be equal to dp of I minus 1 and j. The cost is the same because this x can be there as well and it has no effect. Okay, now consider the cases where this character is something that has some effect. For example, first, consider that this character is, for example, character h. Then what can we say? If it is character h, how our dp's can be updated in this way? What do you guys think? dp of I and 0 is equal to dp of I minus 1 and 0 plus ai. Yes, that is good. There's only one more case that you need to consider. That is very good. Yes, let me write this. Yes, so far it is good. Let's write it here. So we are considering the case where S sub I is equal to H. Well, in this case, dp of I and 0, first let's write it here. In this case, dp of I and 0 will be equal to dp of I minus 1 and 0. This is the case that we do not want to even have h's. So all the h's must be removed. So this is dp of I minus 1 and 0 plus a sub I, because S sub I is equal to h. So this one must be removed. What about dp of I and 1? What can we say about dp of I and 1? Yes. About dp of I and 0, exactly. It is dp of I minus 1 and 0 plus cost of this, the cost of this h. It can be the same as dp of I minus 1 and 1, but there is one more case as well. So dp of I and 1, you're right, one of the cases is dp of I minus 1 and 1, but there is also another case that can be considered for dp of I and 1. Well, the point is that we might have 0. I mean, there's also a possibility that we are at dp of I minus 1 and 0 and we do not remove this character. Then this way we will go to dp of I and 1. So it is minimum of dp of I and I minus 1 and 1 or dp of I minus 1 and 0. Because it is possible that we were at I minus 1 and 0 and we did not remove this character. So in this case, so when we are at dp of I minus 1 and 0, either we remove at this character and stay at the same place, or we do not remove this character and we will go to dp of I and 1. Okay. So these are the two cases that we have. But what about dp of ion 3 and dp of ion 2 and dp of ion 3? Yes, they remain the same because nothing has changed. They are looking for A and R, but we have H, so it has nothing to do with them. So they remain the same. So nothing changes for them. So they are the same. So this is gonna be all if it is H, but what if S of I is A? So we have two other things that we need to consider if S of I is A or R or D. We have three other things to consider. What if S of I is A? Let's write it in a faster way. What is dp of ion 0 in that case? If S of I is equal to A, what is dp of ion 0? Exactly the same. So it's going to be dp of I minus 1 and 0. Because nothing has changed. We're looking for H, but this is A, so it has no effect. What is dp of I and 1? What about dp of I and 1? dp of I and 1 lets H to exist, but it doesn't let HA to exist. So what is dp of ion 1? Exactly, it's gonna be dp of I minus 1 and 1 plus AI. Because we can say that we already had 1, we only consider H's, but this one is 8, so we need to remove it. We must not have it. So we need to remove it, right? So this is the case for dp of I and 1. What about dp of I and 2? What about dp of I and 2? There's a good question. What if there was no H before? Well, the point is that if there is no H before, I've calculated that way in dp of I and 0, so I do not need to worry about it in dp of I and 1. You're right. If there is no H before, we do not really need to remove this character. You're completely right about it. But the point is that that case is considered in dp of I and 0. So I do not need to worry about it in dp of I and 1. So the point is that in my states, I know that exactly what has been matched. So in dp of I and y, I assume that an H is really matched. Okay, so in dp of I and 1, I consider that an H is really matched. Because this second one shows my state. This shows that what is my current state. If no H is matched, I'm sure that this indicator will be 0. So I assume that this is matched. And basically my base case is also like this. When I define everything like this, my base case is gonna be like initially dp of 0 and 0 is 0 because I'm at this point. All the other dp's are inf for me at the beginning. This is the way that I considered it. I was also able to define it like at most this much is matched, at most an H is matched, at most HA is matched. But for simplicity, because this way it is easier to digest that what is going on, I defined it like this. The second value just shows that what is exactly my states. So if it is, for example, 1, it means that an H is matched. Because initially, when we have no elements, it is not possible that an H is matched. We define its cost as infinity. It means that this is not possible. So these are my base cases. And in dp of I and 1, I consider that an H is really matched. That's my state, because this is what my state is showing. Okay. Awesome. So dp of I and 2 exactly. So dp of I and 2 will be updated similar to how dp of I and 1 was updated here. So dp of I and 2 is equal to minimum of dp of I minus 1 and 1 and dp of I minus 2 and 2 and dp of I minus 1 and 1. Okay, so this is the case that it is the same. This is the case that we already had H and now an A is added. So now we had a transition to dp of I and 2. And what about dp of I and 3? If I'm at a state 3, I had to be at a state 3 from previously, because this A cannot move us to a state 3. So we needed to be at state 3 from previously. So this A has no effect on that. So this one remains the same. Okay, what if Si is equal to R? You know, we are finding some pattern. I mean, what happened for A was very similar to what happened for H. It just was based on the second one. You know, in this one, dp of I and 1 was updated from its previous one, and dp of I and 0 needed to add this cost. In this one, it's like this. dp of I and 2 was, we are getting its minimum with the previous one, and dp of I and 1 was added with the cost. So how's it gonna be for the case where S of I is equal to R? How that is gonna be updated? Again, dp of I and 0, it has no effect on dp of I and 0 because it's R and we do not care about R. What about dp of I and 1? dp of I and 1 also same, because it has no effect. dp of I and 1, it cares only about H and A. What about dp of I and 2? It means that we already have H and A matched. So if we want to remain at the same state, we need to remove this R. So dp of I and 2 is equal to dp of I minus 1 and 2, and we need to remove this R if we want to stay at the same state. But what about dp of I and 3? There are two cases. Either previously we were at dp of I and 3, dp of I minus 1 and 3, or previously we were at dp of 2, and now this R is added, and we are at state 3. So these are these two cases. And this said we can calculate everything. So this is for the case where it is R. And what about the case where it is D? Again, it's very similar. So dp of I and 0, again, it has no effect on it. It's dp of I minus 1 and 0. dp of I and 1 is equal to dp of I minus 1 and 1. dp of I and 2 is equal to dp of I minus 2 and 2, I minus 1 and 2. Only where we have dp of I and 3, it means that H and A and R are not matched. H and A and R are matched. So D must be removed from it so that we remain at this state. So it's dp of I minus 1 and 3 plus AI. And we do not even consider the case that we are at 3 and we don't remove AI and we go to a state 4. Because the state 4, it means that we have H, A, R, D. So that is not useful for us. There's no way to find the answer that way. right? So this is how we can find the answer. Is it clear completely? Let me send you the question again. The link of the question is this. If you're okay with that, please use this emoji or put a plus in the chats. Awesome. So this was our second problem. I think we need to go a little bit faster. I think we spent a lot of time. So yes, now maybe we need to accelerate our performance. So let's move on to the next problem. Yes, you need to train. I understand that what you're saying. Yeah, it might be challenging to do two-dimensional DPs and many different DPs. You need to solve so many problems. What I really suggest to you is to try to accept all of these problems that we're discussing in these live streams. I will make a Google Sheets and I will add all of these problems that are covered in these live streams in them, so that you can have all of these problems. I really recommend you to try to solve all of these problems. And over time, you can accept so many problems, and I believe that this can resolve your issue. What is my age? What do you think is my age? What do I look like? At the same time, let me show you the next problem. Do I look like 24, or you already know that I'm 24? Because it was right. I'm 69? Really? No, I'm 24. It was right. I'm not 69. But it was close. Okay. So let me tell you the next problem. The next problem, Gergary and permutations. It says that we have several permutations. We have k permutations of numbers. K is at most 5. And we want to find the longest common subsequence in these 5 permutations. This problem is not LCS. It is very similar to LCS, and we will cover LCS. But it is not exactly LCS because it has k permutations, and we need to find out the longest subsequence that is common in all of them. For example, if you consider these 4 permutations, you see that 1, 2, 3 has occurred in all of them. So a common subsequence, or for example, 4, 2 is also common in all of them. 4 and then 2, or 4, 3. In this one we have 4, 3, in this one we have 4, 3, in this one also we have 4, 3, or 4, 2, or 1, 3. So these are the common subsequences, the subsequences, the arrays, the sequences that has occurred as a subsequence in all of these sequences. So this question asks you to say that what is the longest common subsequence in all of these permutations. Is the statement clear on this one? Maybe. Yeah, we will consider this. We will consider all these solutions. Okay. So in this problem we have k subsequence, k permutations, and we want to find out the longest. All of them are permutations from 1 to n. We want to find the longest sequence such that it's the subsequence of all of them. It has appeared in order in all of these. We want to find the longest such sequence. And we know that n in this problem is up to 1,000 and k is up to 5. N is up to 1,000, k is up to 5. So what I can do, it is a good idea that if for every I and j, I can find out if I can be before j. You know, the point is that in our sequence, I can come before j if and only if in all of the permutations, j has appeared after I. This is the only way that I can be before j in our subsequence. So the question is that, again, if I want to use dp, how can I define subproblems in a way that it helps me? How can I define subproblems? What do you think? How can I define DPs on this problem? What do you think about it? DP of n and k, DP for every array. Okay, any other ideas? Just let's brainstorm about all the ideas. If I want to define some subproblems, I want to find the longest common subsequence in all of these sequences. So now the question is that, how can I define several subproblems for this problem? Okay. Some of your ideas were really good that can help. For example, if I consider I, dp of I, and I consider I as the last element. This is the last element in the CS, in the common subsequence. So dp of I can be the longest common subsequence such that its last element is I. Okay, so dp of I, my subproblem can be this. For example, in here I can define dp of 1 as the longest common subsequence such that its last element is 1. So this is 1 because we know that the only subsequence that is common in all of them and it ends with 1 is 1. dp of 4 is also 1 because nothing can come before 4. dp of 2 is 2 because I can have 4 and 2 or I can have 1 and 2. So I have sequences such that the last element is 2 and the length is 2 as well, and it is the common subsequence of all of the sequences. And dp of 3 is 3 because both because 1, 2, 3 is again a subsequence that ends at 3, and it is a common subsequence of all of the sequences, right? So dp of I can be the longest common subsequence that I can have such that its last element is I. Is the definition clear? If please use some reactions if the definition is clear. Awesome. So now how can we update, how can we calculate dp of I? How can we calculate dp of I? Do you guys have any idea? How can we find out the longest common subsequence such that its last element is I? Maybe in DPs we know that calculating DPs can be done with considering some cases. For example, maybe when we fix the last element, we can try to fix the element before the last. Exactly. This is a very good idea. I can fix some j such that j can occur before I in my subsequence, and then I maximize it with dp of j plus 1. So it's like I'm trying to find out the elements before the last one. So if I is the last element, my question would be, what is the elements? What is the elements before the last one? Before the last one. So if the last one is I, the previous one, for example, can be some j. The only condition is that j in all of my permutations should occur before I. If it has that condition, so the condition for j, the condition is that in all the permutations, j must occur before I. If that's the case, then we can say that dp of I max equal to is not really an operator in C++. Yeah, you just use it as pseudocode. dp of I max equal to dp of j plus 1. Is it clear? So if I have calculated dp of j previously, then I can here find dp of I, and I say that dp of I max equal to dp of j plus 1. So I'm fixing the element before the last one. Okay, I know what is the last element. It is I. Now I'm trying to fix the element before the last one, which is gonna be some j. Okay, so this is how I can find this out. But the point is that there are two main issues. First of all, how can I check this condition? How can I check? There are two issues. The first issue is this. How can I check if j is before I? J is before I in all the permutations. How can I check that out? Enumerate the first and last sequence of I and j in every pair. Well, first of all, this is a permutation. So the occurrences of each number in a permutation is exactly 1. Each number will appear 1 in one time. So if you have a permutation with numbers from 1 to n, each number from 1 to n will appear only once. Hash map set. We can also store the, yeah, exactly. We can store positions. Exactly, we can store the positions. For example, I can just keep, for example, assume that position, pos of I and, for example, L says that what is the position of I, what is the position of I in permutation number L. I can just find that out easily. For example, when I have my permutation P of L and I, let's say perm of L and I, this is my permutation number L. When I see in perm of I and I can simply say that the position of this value, perm of L and I, this is some x, right? This is some x. The pose of this x, the position of this x in permutation number L is equal to I. So basically, after getting in input all the indices, I can easily find out all the positions of all the elements in all the permutations. So I know that what is the position of each of the elements in each of the permutations. This way. So when I know all the positions, now when I want to check the condition for J and I just need to have a for. I just need to have a for on all the permutations L from 0 to k minus 1 to be more precise. And then I just need to check that if, or like I have a flag, and I say that flag and equal to means that this one must also be correct. All of these must be correct. And equal to pose of J and L less than pose of I and L. So also in this permutation, J must come before I. So I pre-compute all the positions of the elements in my permutations, and then when I want to check if J can come before I, the only thing that I care about is that in all the permutations, the position of it is before the position of I. So this way, the first issue can be resolved. So this issue can be resolved. I can find out for each I and J if I can come before J, if J can come before I. So this issue is resolved now. Do you agree with this? Do you agree so far? Please use this emoji or put a plus in the chat if you're okay with that. And if you have any questions, you can ask here. Okay, awesome. So now that we know this, there's one other issue left as well. Well, the point is, before calculating dp of I, dp of j must be calculated. So I need to calculate dp's in an order such that I make sure that if j can occur before I, dp of j will be calculated before dp of I, because dp of I will use dp of j. So my second issue is this. The order of my second issue is the order of calculating dp's. So the point is that if j can come before I need dp of j to be calculated before dp of I. dp of j must be calculated before dp of I. Sorry. Yeah, can you hear me now? Yes, it was FBI for a second, but it is fixed now. Can you hear me well? Okay, yes, sometimes this happens, sometimes FBI comes, but this was the first time that it happened in the middle of the live stream. But I'm really lucky that it was resolved very soon, because sometimes it continues for like 10 minutes, and it was possible that this time it continues for around 10 minutes as well. Yes. Yeah. Yeah, exactly. That's yeah. This is why they are here. Okay. So let's continue it. So the order of calculating dp's matter, and if j can come before I, dp of j must be calculated before dp of I, right? If j can come before I, dp of j must be calculated before dp of I. Exactly. Awesome, exactly. So now the question is that in which order we need to update dp's, but this is the answer. We can just iterate I over the elements of the first permutation. So if you calculate dp's, if you calculate dp's based on their order in the first permutation. Well, the good news is that if you do it based on their order in the first permutation, if j can occur before I, in all the permutations j is before I. So also in the first permutation j is before I. Okay, so the good news is that if j can occur before I in all the permutations, j is before I. So in the first permutation also j is before I. So this way, with a very easy way, we make sure that before calculating dp of I, all the dp's of j's are calculated for all the values that come before I. For instance, in this example, the first permutation is 1, 4, 2, 3. So we can first calculate dp of 1, then calculate dp of 4, then calculate dp of 2, and then calculate dp of 3. And this is not only for the first permutation. If you consider any of these permutations and just update in order of that permutation, it would work. It doesn't matter. For all of them, it works. And because for all of them work, we just say that, okay, let's do it for the first permutation. Let's consider the first permutation. You can consider any of other permutations as well. You can consider the last permutation or anything. And then FBI is really here, sorry. Can you hear me again? Yeah, but they did back down again. No, but sometimes it happens when something is on fire, but I don't think right now anything is on fire. Maybe there's a neighbor on fire. I don't know. So, yes, FBI is on fire, maybe. No one can do it on purpose. This is it's trying to detect, it has some issues to detect something. Sometimes mistakenly it detects something. So, okay. I hope that it doesn't happen again, but was it clear? So that was all we were saying. We will do this in the order of their their occurrences in the first sequence, and then we calculate the dp's based on that. And this way we have all the dp's. Again, if it is clear for you, please use the emojis or put a plus in the chat, and then we will move on to our fourth problem. And guys, if you liked the video so far, if you liked everything that happened, like the sirens or everything, I would appreciate it if you like the video or subscribe to the channel, and also maybe share the video with your friends or anyone who might get benefits from this video. There's no pressure on that, but if you wanted to support my work, you can do this, and I would really appreciate it. And also, again, I must invite you to join our Telegram channel for further discussions. You can join our Telegram channel, and I will add all the links of all the problems in our Telegram channel, and I will make a discussion part for that if you had any further questions about this live stream, you can say there, and you can also tell me about your feedbacks and suggestions about the streams. And please give us your feedbacks. Your feedbacks helps a lot to improve the live streams. In the next sessions, every Friday from 12 to 14 GMT, we're gonna have a live stream, and I'm really trying to improve its quality for you. So make sure to give me your feedbacks. That's really gonna be helpful. You can give feedbacks in the comments in YouTube, or in the comments in the Telegram channel, or messaging me on Codeforces, or putting comments in Codeforces blog posts, anywhere. So yeah, sure, and we will discuss about the topic of the next topic streams in our Telegram channel as well. Yeah, I will put all the links in the description of this video as well after the live stream. Yeah. So let's now move on to the fourth problem. Let me just make sure that okay, let's move on to the fourth problem. The fourth problem is this one, the problem with difficulty 2000, choosing balls. So this is the fourth problem. It says that assume that you have n balls. Each of the balls have some color. The color of the ball number I is C sub I, and the value of the ball number I is V sub I. And you know, you can, when you have a sequence of the balls, the value of the sequence is defined like this. You consider the balls one by one. If a ball is not in the beginning of the sequence and the color of it is the same as the color of the previous ball, we add the value of the ball times A. So if it is ball number I, we will add V sub I, the value of ball number I, times A to our final answer. If the ball is not in the beginning of the sequence and the color of the ball is the same as the previous ball. Otherwise, if it is either in the beginning or its color is not the same as the previous one, we just add the value of the ball times B. So each time as a query, you are given the values AIs and BIs, and you need to consider if your A is equal to this AI and your value B is equal to this BI. And then you need to make a subsequence of all the balls. You can choose several balls. You can make a sequence without changing the relative order of the balls, or in other words, you want to choose a subsequence of the balls in a way that it maximizes the total value. You need to say that what is that maximum total value that we can get. Okay, so each time you are given the values AIs and BIs, which are your A and B's, and you can choose a subsequence of the balls, and you want to maximize its value. And the value is defined as the sum of these values. If a ball is at the beginning or its color is not same with the previous one, you will add V sub I times B. Otherwise, if it is not at the beginning and it's the same with the previous one, the color of the previous one, you add the value of it times A. So you're given all these numbers, and you need to say that what is the answer for each query. Is this statement clear? Okay, awesome. So So, okay, we want to find, we know that Q is up to 500. So we have 500 queries. And N is up to 10 to the 5th. And the color of the balls are up to N. And VIs are up to 10 to the 5th. And also AIs and BIs are up to 10 to the 5th. They can also be negative numbers, but they are up to 10 to the 5th. The absolute value of them is up to 10 to the 5th. So now you want to maximize the value of a subsequence. How can we do that? I mean, again, the first question is that how can we define subproblems, or in other words, states? How can we define subproblems on this problem? Do you have any idea? So we want, the point is that we want to maximize the value of a subsequence, and we only care about the relative color of each two consecutive balls. So what can be the definition of our DP in this problem? We only care about the absolute, we only care about the relative color of the balls. If this new ball has the same color with the previous ball, with the last, if we have a subsequence already, if its last ball has some color, this new ball, it has either the same color or a different color to that one. So we need to, that's the only thing we care about. So what can our DPs be? What our DPs can be? How can I define the subproblems? Well, one thing that I can have is, for example, DP of C. Assume that I'm doing it for every query. So every query will be solved independently. The point is that the constraints on Q and N are in a way that even if I have a solution of O of Qn, it's gonna be good. So if for every query, if I solve the problem in O of N, for every query individually, I solve the problem in O of N, I'm done. And my time constraints are okay. So I can just maybe try to have DP of some C, which says that what is the maximum value that I can have, the maximum value if the color of the last ball is C. So DP of C can be this: the maximum value if the color of the last ball is C. Yes, exactly. Exactly. So my DP is exactly this. And thank you very much, Abhishek. So this is gonna be my DPs. DP of C, I don't know why it doesn't scroll. DP of C is the maximum answer if the color of the last ball is C. Now the point is that, so why do I need to store the color of the last ball? Because when I'm adding a new ball, for example, I have a subsequence. When I'm adding a new ball, I need to know that what is already the color of the last ball. So when this one will be added, I know that if it is the same or if it is not the same with the previous one. So one solution, let's first try to solve with O of n squared. Okay, So first, I want to find a solution with bad time complexity. I mean, I can start from somewhere, and then it's okay. It's okay if my time complexity doesn't work from the beginning. I'm starting with some O of n squared solution. What I can do is to just start over from the beginning and go on all the elements. And for each element, I can just do this. For example, if this is my ball, I can oh, sorry. That was a good point. Thank you. So I can start from with O of n squared solution, and I can say that. So my solution can initially have a bad time complexity. That's okay. I will try to improve it later on. So I can have an O of n squared solution. I can say that when I'm adding this ball, so let's say that, for example, let me move this part to make things more clear. Let's assume that I have added all the balls till here, and now I'm adding a new ball. Okay, now this ball is being added. What can I do? I know that what is the color of this new ball, and I know that what is the value of this new ball. So how can I update all the DPs when I add this ball? And it's okay if my solution is O of n squared. I'm okay with that. So what can I do? Exactly. Exactly. That's a very good idea. We can run through all the possible C's, all the possible colors, and if they are the same color, I will add VI times A to it. Otherwise, I add VI times B to it. And I will update all of them to DP of this new CI, because now the color of my last ball is the color of this new ball. So what I can say is I can have a for call on all the colors from 1 to n. And I can say that either I will not add this ball to them. So if I do not add any ball, DP of call remains the same. So DP of call is equal to DP of call. I'm just writing it. There's no need to write this because this is something that has no effects. But I'm just writing it to make everything clear. I'm saying that if I do not add this ball, nothing changes. DP of call is DP of call. So it's possible that I will not add this ball and nothing changes. But if I add this ball, CI, there are two cases. Either if call is equal to CI, I can say that DP of CI will be max equal to DP of call plus A times VI, else DP of CI max equal to DP of CI max equal to DP of call plus B times VI. So what we can say is that I can have a for on all the colors, and I can say that DP of CI will be updated from all the possible colors that could be the last color previously. And this way I can update everything. This way I have a solution with O of n squared, and it works perfectly. It's just a bit slow, but it works perfectly. It works correctly. Is it clear? Does it completely make sense? Okay. So now how can I improve it to a better time complexity? Do you have any ideas for that? So think a little bit on it. It bothers me that that light is off there. So you think a little bit on this and I'll turn that on. So think about it and write in the chat if you had any solutions till I turn that light on. Okay, sorry for that. Now it's better. Okay. Binary search. Okay, that's an idea. We will consider that. I mean, we will analyze that. Maybe add A to all. These all can work. I mean, these all are good ideas. What we can do, the main idea that we can do on this problem is like this. Let's try to, for all the DPs, let's keep the two maximum DPs, the two maximum DPs. So what I mean is to keep some mx1, which is your maximum DP, and some mx2, which is your second maximum DP, the second best one. The point is that, guys, there are two cases. I mean, in this part has no effect, so I can remove it at all. It has no effect on DPs, so it doesn't matter at all. But about these parts, there are two cases. Either the previous color, the previous ball has the same color, or the previous call has a different color. If it has the same color, DP of CI will be updated from its own color, from this call is equal to C sub I. Or if it is not, it's only enough if I update it from the maximum DP of call. So I have several DP calls. I can update it from the maximum possible DP of call. Okay, so the point is this. If I keep the two maximums, one of them, at most one of them is equal to DP of CI. So DP of CI can be at most one of them. If either maximum is not DP of CI, so in here I can just consider mx1 plus b times v. Or mx1 is equal to DP of C1, which is okay. In here I will consider mx2, the second maximum. So the point is that I will keep the two maximum DPs. I will keep, sorry. Okay, it crashed again. So the point is that I can keep the maximum two DPs. And if I do this, if I only consider the two maximum DPs, I can just find the maximum one which is not equal to CI. And this way, I can easily find that out and update all the DPs. In O of 1, I don't need to have a for on all the possible DPs anymore. And this makes our work way easier, right? So what I do is to just try to keep we try to keep the two maximum DPs, and when I add a new ball, I have two conditions. First, I say that if DP of CI was equal to mx1, it means that I need to consider mx2. Okay, so let's have a comment here. And you have to consider, or let's say I have to consider mx2. mx2. What do I say in this case? I say that DP of CI first will be max equal to DP of CI plus A times Vi. And then I say that dp of Ci max equal to mx2 plus B times Vi. And then I need to update mx1 and mx2. How do I do that? Now dp's are all updated. dp of Ci is updated, and I know that the rest of dp's will not be updated at all. So now I need to say that mx2 is max equal to dp of Ci, and then if mx2 greater than has turned into greater than mx1, swap mx1 mx2. So then I will update mx2, and if mx2 has turned greater than mx1, I need to swap them, because now mx2 is the greatest one, so it should be swapped with mx1. Otherwise, I just say that dp of Ci, it's almost the same dp of Ci. So I need to copy and paste it here. Again, dp of Ci is equal to dp of Ci itself plus A times Vi, and dp of Ci this time is equal to mx1 plus B times Vi, because mx1 is not equal to Ci. And then I can just say that mx1 itself, because mx1 was for Ci, and now Ci is updated, I can just update mx1, because mx1 is related to Ci. I mean, is based on Ci, and now Ci is updated. So I can just directly update I can directly update mx1. So mx1 is equal to max of mx1 and dp of Ci. Or I can even say dp of mx1 equal to dp of Ci, because mx1 was equal to dp of Ci, and now maybe dp of Ci has became bigger. dp of Ci has not turned smaller, because it's max equal to something. So maybe it has become bigger, and mx1 shows dp of Ci. So I need to say that mx1 equal to dp of Ci to reflect the changes in dp of Ci. Is it clear? So this is the idea that helps us to optimize our solution. So this was an idea for dp optimization. We call this thing dp optimization, when we have an idea to optimize our dp and make our time complexity better. Hi, d space. We can just say that O of n squared has turned into O of n for each query. And when each query can be solved in O of n, our total time complexity is going to be O of qn. And that's going to be everything we have here. Is it completely clear? Shall we move on to the next problem? Shouldn't it be vice versa? What should be vice versa? Anything here was not okay? Do you have any issues with any of the parts here? Two cases handling. No, in this case I say that if dp of Ci was equal to mx1, then I know that the first maximum is for dp of Ci. So I need to consider the second maximum here, because second maximum is the maximum of all the elements not equal to Ci, all the different colors. So I need to consider mx2 in this case, and I will also update mx2. And in this case, if it is not equal to mx1, it must be updated from mx1, and I will update mx1. Okay. Hi, nice, from Vietnam. Where are you guys all from? Can you guys say where are you from? I personally am originally from Iran. Right now I'm living in the US. What about you guys? Romania, Serbia, awesome. Wow. Serbia, India. Nice. Syria. What a wonderful place. Which of the places? Since dp of ci is equal to mx1, mx1 corresponds to dp of ci, therefore we shouldn't update mx2. No. Oh, now I see what you're talking about. Yes. Thank you very much. Yes, it's early morning in here, but for you guys it's evening, I know. But yeah, in here it's early morning. Thank you. Yeah, that was a very good point. Thank you very much. You're right. So these two parts must be swapped. It's vice versa. So in this case, because dp of ci is equal to mx1, only mx1 must be changed. But in this case, mx2 must be changed. That was correct. I need to move here. This one as well. Okay, so I hope that you understood what happened, because in the first case, dp of ci is equal to mx1. The only mx1 will be updated. But in the second case, because dp of ci is updated and mx1 reflects dp of ci, this c sub I, only mx1 will be updated. But in the second case, mx2 must be updated, and then if mx2 is turned greater than mx1, they must be swapped. Yeah, I know, it's evening here. In here is 10 minutes to 10, and I have to leave at 10, so we have 10 minutes left. You have to be faster. So is it clear, guys? Is everything clear here? There was just a tiny change. The updates of mx1 and mx2 was swapped. In this case, where mx1 reflects dp of ci, I should only update mx1 after updating dp of ci. In this case, I should update mx2, and then if mx2 was greater than mx1, swapped. Okay, awesome. So now let's move on to the next problem, the last problem of today. The last problem for today is pig and palindromes. This problem, let me send you the link. Well, this problem says that assume that you have a grid on each cell of it. You have an n by m grid. You want to go from the top left corner to the bottom right corner. Each time you can move to the right or to the bottom. Okay, you can move rightward or downward, and you want to make sure that your path will make a palindrome string. For example, in this case, we know that each of the cells has a character, has a lowercase letter, and for example, in this case, we have A. It is a palindrome. Also, in this case, for example, if we have A, B, this is also palindrome. So you need to count that in how many ways. We have a path from the top left corner to the bottom right corner such that it forms a palindrome string. For example, in this one, these are three cases, and the three cases can be seen here. Okay, is the statement clear? N and M are also up to 500. So N and M are up to 500. And we want to find out the number of paths from the top left corner to the bottom right corner such that it forms a palindrome. Okay, guys, the point is that what is the length of the path? What is the length of the path if we start from the top left corner and go to the bottom right corner? Do you agree that the path, the length of the path is equal to n plus m minus 1? Yes, we need to check that if a of a and a of 1 and 1 is equal to a of n and m. That's right. So let me see. So the first thing is to check if, okay, it's not working. So let me first explain in here a little bit till it gets fixed. The point is that the first one, as you say, a of 1 and 1 must be equal to a of n and m. That's right. So, okay, awesome. Everything's are collapsing. So, all is fine. Let's continue. A of 1 and 1 must be equal to a of n and m. So, now the question is that how can we make sure that our path from the top left corner to the bottom right corner will be a palindrome? What is the length of our path? What is gonna be the length of our path? Okay, I see that my my video is not very good. Yes, our length is gonna be n plus m minus 1. So, okay, now it's working. So the length of our path is gonna be n plus m minus 1. It must be even, and also a of 1 and 1 must be equal to a of n and m, right? So these are what we need to make sure that are okay. A of 1 and 1 must be equal to a of n and m. But also there's one other thing that we can say. We have several diagonals, and we know that each time when we go forward, we will move on these diagonals. So we know that our first move is in this diagonal, our second move is in this diagonal, our second character, our third character is in this diagonal, our fourth character is on this diagonal, and so on. We have several diagonals, and each of our characters will be from there. I'm sorry, I said that it is even. Yeah, no, it doesn't need to be even. Sorry, I presume that our string must be an even length palindrome, but it's not. Yes, you're right. It doesn't need to be even. I'm sorry about that. Only the length of it is n plus m minus 1, and we have several diagonals, and each of the characters are chosen from one of these diagonals. So you know that exactly which character is chosen from the first diagonal, which character is chosen from the second diagonal, and so on. And you know that n and m are up to 500. What is the length of each diagonal? What is the maximum length that each diagonal can have? What is the maximum length that our diagonals can have? Yes, exactly, minimum of n and m. So each diagonal has also at most 500 cells, and we know that each time it's like initially we can have like 2 pointers, one on this diagonal, one on this diagonal, one on this diagonal. Each time both of them come one step closer to each other. Each time each one of them come one step closer to each other. And the point is that if you are at cell number I of this diagonal, when you go to the next diagonal, for example, if you are here, if you are at this cell in this diagonal, then you have two choices for the next diagonal. Either you will go to the cell in the same row, or you go to the cell with the in the next row. And also in here, you have two choices for which diagonal you will move to. So the point is that you can have a three-dimensional dp of I and j and k, which means that we are at step number I. We are at step number I. You know, at the first step, you know that we are in these two diagonals. In the next step, we are gonna be in these two diagonals. In the next step, we're gonna be in these two diagonals. So our step says that in which two diagonals we are right now. So we need to store that in which diagonals we are at right now. And then j and k says that in which cell of the first diagonal we are and in which cell of the second diagonal we are. Okay, so we just keep that. What are the two diagonals that we're at? We are just moving at the same time from the beginning to the end and from the end to the beginning. And we are matching them one by one. We are starting both from the beginning and from the end, and we are trying to match the characters with each other. So we know that each time from each state of the DP, we have 4 possible next states. Because each one of these cells have at most 2 choices for the next rows. So when we go to I plus 1, dp of I plus 1 and something, we have 4 choices for the new j and for the new k. And we need to update all of them, and only we can have a dp if that new dp that we're gonna be at can have matching characters. I mean, the characters are the same in those cells. In that way, we can go to these characters, and at the end, when these 2 cells reach the same diagonal or reach 2 adjacent diagonals, we can just add to our answer in that case. So whenever they were adjacent to each other or they were on the same cell, we can add that value to our answer. And this way we know that, and this way we can simply find out our answer. Okay, so after they were either next to each other or they were at the same cell, we can just add that value of dp to our answer. Does it make sense? So the point is that we have diagonals. Each time we will start from the first diagonal and from the last diagonal and move them closer to each other. And each time, so we are both moving from the beginning to the end and from the ends to the beginning. And we are each time matching 2 characters with each other. So we are moving and we are matching the characters with each other. And as we go forward, when we reach this some cells which are adjacent to each other or they are in the same cell, we will add that dp to the answer. The only remaining thing is that O of n cubed memory is not very good. So can you have any idea, can you give me any idea to just optimize our memory? I mean, for time, n cubed is okay, but for memory, n cubed is a bit high. And we want to just optimize memory. So we just want to optimize memory and not time. About time, we're good with that. It's good. N cubed is good for time. We just want to optimize memory. How can we do that? Yes. The diagonals make sense, but what would the recurrence be here? Well, the recurrence is that, as I said, we only from J, there are two next cells that we can be in them. So nj has 2 possible values, and also nk has 2 possible values. So the next j and the next k have 2 possible values. So we have 4 possible next states. 4 possible next states. So this way we can find out that when we go to the next row, to the next diagonals, in which cell of them we're gonna be at. So we have 4 possible next states. So our DP will update 4 DPs. Okay. And yes, about the memory issue, we can stop keeping I we can both remove I at all, but that can be a little bit problematic. There's something that has less issues. I mean, removing I is also correct. It is possible to remove I at all. But there's something that is simpler to explain, and this is like this. You don't need to keep I. You can just keep I modulo 2. I can be stored modulo 2 because we only care about each time. We only care about the previous I. So we assume that our I is equal to 5. When our R is equal to 5, we only use I equal to 4. We only use the previous one. But we will never use I equal to 3. So the point is, at this point, we can remove the row for I equal to 3. And we can update I equal to 5 at the same place. So we can rewrite that row with the values of I equal to 5. So if I keep I modulo 2, all the even numbers will update the row 0 and all the odd numbers will update row 1. So the point is that when I come to 5, I will write again on the same row that 3 was 3 wrote on that before, but now I will remove what 3 has wrote, because it is not going to be useful in the future. I'm not going to use it in the future. I will update it again with the values for I equal to 5. So each time when I'm at I, first I make I empty, I make row I empty, because the previous value that was here is not useful anymore. And I need to update everything from not of I, which shows that what was the previous cell, and I will write again on I. I will write again on I. So this way I can just keep I modulo 2. And this way my memory will be turned into, my memory will be optimized to n squared. This is a very useful idea. In so many problems we will keep an element like I modulo 2, and this can reduce our memory complexity by a factor of n. And it makes everything so much better. Is it clear? Oh, what a bad picture I have. If it is clear, please again use the emojis or put a plus or anything. And guys, again, I would appreciate it if you can like the video and share the video with others if you want it. And again, I invite you to join our Telegram channel. I will add all the problems there. I will also add the problems in the descriptions of this video. And I'll see you next time in our next session, next Friday from 12 to 14 GMT. I hope you have enjoyed it. Do not forget to put a comment on this video. I would appreciate it. Tell me about your feedbacks, and also in our Telegram channel, tell me about how can we improve these live streams. Yeah, sure, we will cover graph theory as well. We will discuss about these things in Telegram channel. Maybe I put another vote. Thank you very much. Thank you very much, guys. Maybe I will put another vote on the Telegram channel so that you can vote for which topic you want to be discussed. What is the meaning of recurrence? It's about from which state you will update this state. You have a sub-problem. Recurrence is about calling the same instances of the problems, calling the smaller instances of the same problems, and try to use them. Thank you very much. I'm really glad that you enjoyed it. And I hope that we will continue it for many weeks, and we can cover every possible important topic in competitive programming. Thank you very much, guys. Thank you. So see you in the next live streams. Tomorrow we have a contest, Codeforces contest. So I think I'll see you tomorrow if you participate in the contest. And then in the next Friday we have another topic stream. Thank you very much, guys. See you next time. Bye-bye.